Hey guys, today we're going to talk about graphing rational functions. So I've got a list of steps here. They're not the only order that you could do this in, but I found this is kind of the easiest order to tackle your graphing rational functions in. I will say that no matter what, you should always do this first step first, and that is to factor and find any holes that you may have in your graph. So if you're looking for holes, that's going to happen when the numerator and the denominator have a factor in common and they cancel out with each other. So you have holes when something in the top can cancel with something that's in the bottom of the fraction. So the reason you need to check for holes first is that that hole is then going to cancel out and it's going to change your equation, which then changes how your vertical asymptotes and horizontal asymptotes and x and y intercepts and everything is going to look in the rest of the graph. So I would always find your holes first, and then the rest of the steps can kind of be done in whatever order you would like to. I usually start by finding my asymptotes. So I would find my horizontal or oblique asymptotes, and that kind of tells me what the end behavior of my graph is. So that's the rhyme that I talked about in our last set of notes, the high over low, then no, low over high, 0 equals y, and same over same, coefficients is the game. Then after that, I'm going to move on to my vertical asymptote, which is where I set the bottom of the fraction, the denominator, equal to 0. That's like finding my domain restriction. After I find my asymptotes, I need some actual points to put on my graph, so I usually start with my intercepts. You can find the x-intercept by setting the top of the fraction, the numerator, equal to 0, and you can find the y-intercept by plugging 0 in for x. And then if you need more points to help you graph, you can make a table and help you get some key points that will help you see what your graph is going to look like. So we're going to walk through 4 examples and we're going to just graph them following these steps. So example 1, our first step, is to factor and see if there are any holes. So if I'm looking at this one, on the top we have 1, which we can't really factor. The bottom is x minus 4, which we also can't really factor. So it's already factored for us. Nothing's going to cancel out. So there are no holes in this graph. So I'm going to move on to finding my asymptotes. I'm going to start with my horizontal asymptote. So that's my high over low, low over high, or same over same. If there's no x in the top and then an x in the bottom, that would be my low over high, which means 0 equals y. So I'm going to have a horizontal asymptote going across at y equals 0 on my axis here. Do your best to kind of draw it. I know that the axis is a little bit of a thicker line, so sometimes it's harder to draw it where it shows up. So just kind of do your best there. Then I'm going to look for my vertical asymptote. I find my vertical asymptote by setting the denominator equal to 0. So that's x minus 4 equals 0. I'm going to add 4 to both sides, so I get x equals 4. So I'm going to have a vertical asymptote going up and down at 4 over here. Okay, now I need to find some actual points to put on my graph, so we're going to try and find some intercepts here. I'm going to start with my x-intercept. It's where we take the top and set it equal to 0, our numerator. Our numerator is just 1 though, and that can't ever really equal 0, so that means that we have no x-intercepts, that there are none. Oop. So, no x-intercepts, that doesn't really help us a whole lot. Let's see if we've got a y-intercept that'll help us. We find the y-intercept by plugging 0 in for x. That's going to be 1 over 0 minus 4, which gives us negative 1/4. So my y-intercept is 0, negative 1/4, about right here. So we've got 1 point. We might need a few more. So let's make a table. That's our step 6 to get some extra points to help us out here. So make a table over here. And I'm going to be strategic about what I put in my table to help me with my graph. If my asymptote is over at 4, I'm going to pick some points that are close to my asymptote to help me with my graph. So I'm going to plug in 3, and I'm going to plug in numbers on either side of my asymptote to help get me some points there. So if I plug in 3, that's 1 over 3 minus 4. So 1 over negative 1, which is negative 1. So I've got the point 3, negative 1. If I plug in 5, that's 1 over 5 minus 4. So 1 over 1, which is 1. So we've got 3 points now, which remember I said you always need at least 3 points to help you draw your graph for this class. So we can go ahead and connect our points. If you want more points, that would never hurt to get more points. So you could plug in 6, you could plug in 7, you could start plugging in other points like 1 or 2, help you get more points. But I'm going to go ahead and draw it. It's going to come over here through my y-intercept and then through the other point I have and come down with my asymptote. And then on the right side, it's going to come down and then over. And there's my graph. Okay, let's look at the next one. I'm going to start the same way. I'm going to factor and see if there are any holes. For this one, the top, x minus 5, does not factor. But the bottom does factor. If I use my big X to help me factor, I'm going to put a 15 on the top and a negative 8 on the bottom. So negative 3 times negative 5 gets me to 15. Negative 3 plus negative 5 gets me to that negative 8. So it's going to factor as x minus 5 and x minus 3. And those x minus 5s are going to cancel. So that means that I'm going to have a hole. And it's specifically where that x minus 5 equals 0. So I can add 5 to both sides, and I'm going to have a hole at 5, at x equals 5. And for the rest of the problem, I'm going to use what's left. So that means in the top, I'm left with just 1, because that x minus 5 was canceled out. And in the bottom, I'm left with x minus 3. So for the rest of the problem, I'm going to use this fraction right here to find like all my asymptotes and my intercepts and graph it. So for my hole, I do need to know what the y value is that goes with that hole. So I need to take that 5 and plug it in. When I plug 5 in, that's going to be 1 over 5 minus 3, which is going to give me 1/2. So my hole is at 5, 1/2. You can come over here, and when I draw this on my graph, I'm going to draw it as an open point since it's a hole at 5, 1/2, so about right there. And then I'm going to use that 1 over x minus 3 to find the rest of my characteristics. So my horizontal asymptote, vertical asymptote, x-intercept, y-intercept, all of that fun stuff. So let's find our horizontal asymptote. If we look at this, we've got 1 over x minus 3. So once again, we've got a low over high, like we did up here. So if we've got low over high, then that means 0 equals y. So it's going to go across at 0. So there is my asymptote. Find my vertical asymptote. I'm going to set the bottom equal to 0. So x minus 3 equals 0. Add 3 to both sides. So x equals 3. Vertical asymptote going up and down at 3. Find my x-intercept. That's at the top equal to 0. But once again, we've just got 1, which can't equal 0. So that means that we have no x-intercepts. I'm going to write none. And to find my y-intercept, I'm going to go ahead and plug 0 in for x. So that's going to be 1 over 0 minus 3, so negative 1/3. So 0, negative 1/3. That would be about right there. Okay, this time I've got a point and a hole, so that's a little bit more than we had last time. But we still need some more points to help us, because remember, you need at least 3 points when you draw a graph for this class. So let's make a table and get some more points. There we go. Okay, so I'm going to plug in, if my asymptote's over at 3, I'm going to plug in 2, and I'm going to plug in 4. So 1 over 2 minus 3 gives me 1 over negative 1, which is negative 1. So 2, negative 1. So I can come over and down. And when I plug in 4, I'm going to have 1 over 4 minus 3. So 1 over 1, which is 1. This point right here. So I can come down and over. And there's my graph. Okay, let's look at some more on the back. And let's step it up a little bit. With example 3, now we've got one that we've got to factor the top and we've got to factor the bottom. So when I'm factoring the top, I can use my big X to help me factor. I'm going to have 2 times 2 on top, which is 4. Negative 5 on bottom. It's going to be negative 4 times negative 1 to give me a positive 4. Negative 4 plus negative 4 to give me negative 5. But for this one, when we're factoring, we do have that a is not equal to 1. So you can either use your slide and divide, your box method, your factoring by grouping. I'm going to use slide and divide here, so that means I would put x minus 4 and x minus 1, but I'm going to take this 2 and try and divide both of them by 2. 4 does divide by 2, so that's x minus 2, and here it doesn't, so I'm going to slide it up and make it 2x minus 1. So that means that my factors are x minus 2 and 2x minus 1. The bottom, x squared minus 4, is a difference of 2 squares, so it's going to factor as x minus 2 and x plus 2, because the square root of 4 is 2. So you can see our x minus 2's are going to cancel, so that means that we're going to have a whole. We're going to have x minus 2 equals 0. Adding 2 over, we're going to have our whole at x equals 2. And that means for the rest of the problem, we're going to look at 2x minus 1 over x plus 2, because that's what's left when we cancel out where our whole is. Okay, when I plug 2 into that to find my y value, that would be 2 times 2 minus 1 over 2 plus 2. So 4 minus 1 over 4, which is going to give me 3/4. So my whole is at 2 3/4. About right there. My horizontal asymptote, this time we have a same over same. We've got x to the first power over x to the first power. So if I have same over same, coefficients is the game. So I'm going to take the coefficients. The coefficient of the top is a 2. The coefficient of the bottom is a 1. So 2 divided by 1 is just 2. So my horizontal asymptote is going to go across at 2 this time. My vertical asymptote, I'm going to take the denominator and set it equal to 0. So the denominator is x plus 2. When I subtract 2 from both sides, I get x equals negative 2. So it's going to go up and down at negative 2. And this time, when I try and find my x-intercept, I'm going to take the top and set it equal to 0. And I do actually get an x-intercept. I'm going to add 1 to both sides. So 2x is equal to 1, and divide both sides by 2. So I get x is equal to 1/2. So my x-intercept would be 1/2, 0. So about right here. And for my y-intercept, when I plug 0 in for x, I'm going to get 2 times 0 minus 1 over 0 plus 2, which is negative 1/2. So I get 0, negative 1/2, about right there. Now I do have 3 points this time, 2 points in my hole, but they're all on the same side of my asymptote. So in order to figure out what's on the other side of my graph, I still need to make a table. So I'm going to make a table so that I can figure out what's going on that left side of my asymptote. So if my asymptote's at -2, I'm going to plug in some things on the left side like -3 and -4. So if I plug in -3, that's 2 times -3 minus 1 over -3 plus 2. -6 minus 1 over -1. -7 over -1 is 7. So -3 up 7. Go up here. If I plug in -4, I have 2 times -4 minus 1 over -4 plus 2. So -8 minus 1 over -2. So -9 over -2, which would give me 9/2 because the negatives cancel. So -4 and then 2, 4, 6, 8, 9/2 would be right there. So 2 points would be enough to connect my points and draw a curve. Over here I've got 3 points, so I can connect those. And there's my curve. And our last example, we're going to start the same way we started all the other ones. We're going to start by factoring. So if we're looking at the top this time when we're factoring, it's got 3x squared minus 3x. So all I can do here is take out a greatest common factor. It's not a difference of squares because we've got 3, which is not a perfect square, and it's 3x, so it's a little bit different. We've only got 2 terms, so we can't do our big x factoring, so we're just going to take out that GCF of 3x, and then I'm left with x minus 1. On the bottom, I can use my big X to help me factor. So when I do that, I have a -12 on the top and a 1 on the bottom. So 4 times -3 gets me to -12, and 4 minus 3 gets me to 1. So I just have x plus 4 and x minus 3. Because my a term is 1, I don't have to worry about slide and divide or anything like that here. And nothing cancels out here, so we have no holes. I'm gonna move on to step 2. And for step 2, when I'm looking for my horizontal asymptote, I want to look at that multiplied out version. So I'm going to look at the 3x squared and the x squared, not the version I just factored. The version I just factored is going to be helpful when we get to the vertical asymptote and the x-intercept and y-intercepts, but for the horizontal asymptote, I really want to be able to see the degree, so really using the multiplied out version is a little bit better. And you'll see that we have a same over same again, which means coefficients are the game. So this time we've got a 3 on the top for the coefficient and a 1 on the bottom. So that means that we have 3 divided by 1, which is 3. So my asymptote is going to go across at 3. For my vertical asymptotes, this time I did say asymptotes because we do have two. I've got x plus 4 that's going to be equal to 0 and x minus 3 that's going to be equal to 0. So I can subtract 4 here and get x equals negative 4. And I can add 3 here and get x equals 3. So I've got two vertical asymptotes this time. A little bit different. We'll talk about what that means for our graph in a little bit. So there's our two vertical asymptotes. And when I find my x-intercept, I do also have 2 again, because in the numerator I've got a 3x that's going to equal 0 and an x minus 1 that's going to equal 0. Over here I can divide by 3, so x equals 0, and I get just 0, 0. And over here I'm going to add 1, so I get x equals 1, and the point 1, 0. So having the 2 points next to each other like that probably means that I'm going to have some type of like parabola shape in the middle right there. And then for my y-intercept, I can plug 0 in. So I'm going to have 3 times 0, 0 minus 1. And then on the bottom, 0 plus 4 and 0 minus 3. So I get 3 times 0 times negative 1 over 4 times negative 3, which is 0 over negative 12, which is just 0. So I get the point 0, 0, which you'll notice is already on there because it's also an x-intercept. Okay, we only have 2 points, and we also have 3 different sections of our graph here. So we definitely need to make a table so that we can find some other points to put on our graph. So I'm going to make a table, and I'm going to make it kind of a big table because we're going to need to find probably a lot of points here. I'm going to start on that far left over there. And if my asymptote is going up and down at negative 4, I'm going to plug in negative 6 and negative 5. So if I plug in negative 6, so you can plug it into the original one that you had or the factored one, whichever one you prefer. I'm going to plug it into the factored one. So that's 3 times negative 6, and then negative 6 minus 1 over negative 6 plus 4 and negative 6 minus 3. So 3 times negative 6 is negative 18, and negative 6 times negative 1 is negative 7 over negative 6 plus 4 is negative 2, and negative 6 and negative 3 is negative 9. And so the reason that's kind of helpful is because I'll notice on the bottom I can have negative 18 times negative 7 on the top still, but negative 2 times negative 9 is 18. And so those are going to cancel out. So it's just negative 1 times negative 7, which would be 7. Down. And so I have negative 6, 7. Okay, if I plug in negative 5, 3 times negative 5, then I have negative 5 minus 1 over negative 5 plus 4 and negative 5 minus 3. So negative 15, negative 6, and that's going to be negative 1 times negative 8. So on the top, I have negative 15 times negative 6, which is going to give me a positive 90. On the bottom, negative 1 times negative 8, which is going to give me 8. I can divide both of those by 2, which would give me 45 over 4, which is about 11.25, yeah, 11.25. So that's kind of off our graph, but I'm gonna put it like about right there. And that gives me enough points to connect up here. And so that's the left side. In the middle, I've already got 2 points. And I kind of said that we're probably going to have a U shape since we've got those two x-intercepts that are so close to each other. And so just to double check, you could always make another point, but I'm going to go ahead and connect it just to kind of save us some time on our video here. I'm going to come up through those and then it comes back down over here. So what we really need is the points on the right side. So on the right side over here, our asymptote is going up and down at 3. So I'm going to plug in 4 and I'm going to plug in 6. I picked 6 for a very specific reason that we'll talk about in a second, but let's start with 4. So 3 times 4, then 4 minus 1 over 4 plus 4 and 4 minus 3. So 12 times 3 over 8 times 4 minus 3 is 1. So if I'm looking, 12 times 3 is 36 over 8. And those don't, we're both divisible by 4. 36 by 4 is 9. 8 by 4 is 2, so 9 halves. So 4 and 9 halves. So 2, 4, 6, 8, right there. And then if I plug in 6, I'm going to have 3 times 6 and 6 minus 1 over 6 plus 4 and 6 minus 3. So 3 times 6 is 18. 6 minus 1 is 5. 6 plus 4 is 10. 6 minus 3 is 3. So 18 times 5 is 90. 10 times 3 is 30. 90 divided by 30 is 3. But if you look, 3 is where our asymptote is going across at. So the reason I picked that is so that you could kind of see that when we're looking at vertical asymptotes, we'll never touch our vertical asymptotes, but it is possible for our graph to touch our horizontal asymptotes. So our graph is going to come down this way, and it's going to kind of touch that way and bounce back up and level out. Our horizontal asymptotes are dealing with our end behavior of our graph. So it's asking as we go off to infinity on the right side and negative infinity on the left side, what is happening? But in the middle there, where we're kind of close to 0, which 6 is kind of close to 0 when we're talking about infinity, it is possible for it to cross the asymptote or touch and to kind of bounce off the asymptote like it does here. So just kind of be aware of that as you're graphing these problems. Okay, also I know I did everything on the table here by hand. You guys do have calculators, so you can use those to help. But I just want to make sure we remember how to do stuff by hand so that when it comes time for AP Calculus or other classes where you don't necessarily get calculators, you're prepared for that as well. So you guys make sure you get started on your assignment that goes with this. Let me know if you have any questions and have a good day.